If one chairman is selected, then the remaining 8 minus 1 is 7, P1 is a vice chairman. So the permutation of n different things taken or at a time is given by NPR is equal to n factorial divided by n minus r factorial. The arrangement of 9 numbers taking 3 at a time is a given problem, that is nothing but 9P3. Since the required number is an even number, therefore the unit place can be filled by any one of these 3 even numbers. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class, we have discussed regarding the problems based on permutations and also the problems based on a fundamental theorem of counting. Today in this session, I will take some statement problems on permutations. So the problems based on the statement, so the number of arrangement of elements or the numbers or the words or in an English alphabet. Now, so let's just recall the formula for permutation. So that is NPR, permutation, NPR. So the permutation of n different things taken or at a time is given by NPR is equal to n factorial divided by n minus r factorial. Now, let us take a first problem. What is the first problem? How many 3-digit numbers can be formed using the digits 1 to 9 if no digit is repeated? So, we want to form a 3-digit number. This is a 3-digit number, unit, 10, 100. So, this is the 3-digit number. So, here, how many 3 digits number can be formed using, how many digits are there? 1 to 9. There are 9 digits. So, from this we are going to select, how many we are going to select? 3. So that means here this is nothing but the permutation of the selection of 9 different things taken 3 at a time, that is called NP3, that's it. So what is the given problem here? Just how many 3-digit number can be formed using the digits 1 to 9 if no digit is repeated, means this is nothing but the arrangement. The arrangement of 9 numbers taking 3 at a time is a given problem, that is nothing but 9P3. Just find out the value of 9P3. What is 9P3? 9 factorial divided by 9 minus 3 factorial, that is factorial 9 divided by factorial 9 minus 3 is 6. So this can be written as 9 factorial is 9 into 8 into 7 into factorial 6 divided by factorial 6 and 6 gets cancelled. What is this equal to? Multiply. So 9 into 8 into 7. So this is equal to 504. So in 504 ways, the 3-digit numbers can be formed using the digits 1 to 9. That's it. Now move on to the next similar type problem. In how many ways the 3-digit even number can be made using the digits 1, 2, 3, 4, 5, 6, 7. So here the digits are 1, 2, 3, 4, 5, 6 and 7. With this we are going to form even. Just find out how many even numbers are there. Now here, so how many even numbers? 2, 4 and 6. So the even numbers are even numbers. There are 3 even numbers, 2, 4 and 6. So how many 3-digit even number can be formed from 1, 2, 3, 4, 5, 6 if no digit is repeated? Same problem as that of the previous one. Here we have to select the even numbers. This is unit place, 10 place and the 100 place. Right. Now, since the required number is an even number, therefore the unit place can be filled by any one of these 3 even numbers. So 2, 4, 6. This any one of these 2 even numbers can be filled in unit place. So this can be filled in how many ways? We are going to fill this place by 3 ways. So the unit place can be filled by the even numbers 2, 4 and 6 by 3 ways. So the remaining 2 places, that is the 10th and 100th place, can be filled by the remaining numbers. So if you take one value from this, the remaining 1, 2, 3, 4, 5. So these 2 places can be filled by 5 2p ways. Right. So therefore the required arrangement is equal to, therefore the required arrangement is equal to 3 into 5p2 ways. That's it. The required arrangement is 3 into 5p2 ways. Now what is this equal to? So 3 into 5p2 means 5 factorial divided by 5 minus 2 factorial. So that is nothing but 3 into 5 factorial means 5 into 4 into factorial 3 divided by 5 minus 2 factorial is factorial 3 gets cancelled. 5 into 4 into 3, that is 3 into 20, that's equal to 60. So in 60 ways we can form 3-digit even numbers from 1, 2, 3, 4, 5 and 6. That's it. Okay. So very simple problem. Just to get an even digit number from 3-digit even number from 1, 2, 3, 4, 5, 6. Just first find out how many even numbers. There are 3 even numbers. So the unit place can be filled by these 3, any one of these 3 even numbers in 3 ways. And the remaining 2 places, that is 110th place, can be filled by the remaining 5 letters, 1, 2, 3, 4, 5 letters with the remaining 2 even numbers. So that can be done in 5p2 ways. Therefore, the required arrangement is equal to 3 into 5p2. That is nothing but 5p2 means 5 into 4 into factorial 3 divided by, that is 20 into 3 is equal to 60 ways. So in 60 ways we can get 3-digit numbers, 3-digit even numbers from 1 to 6. Now move on to the next problem. From a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position? So in a committee of 8 persons, how many ways we can choose a chairman and a vice chairman, assuming one person cannot hold more than one position? So just very simple. How many persons are there? There are 8 persons. How many persons? We are going to select only 2, that is a chairman and a vice chairman. So the number of persons is equal to 8. How many persons we are going to select? To select a chairman, first what we want to select, one is a chairman, and another one is a vice chairman. So this is 2 persons we are going to select. So out of 8 we are going to select 2, right? So here the chairman can be selected in so out of 8 persons we are going to select one chairman, that is 8p1. Already one person is selected, so the remaining 7p1 can be used to select the vice chairman. So therefore the number of arrangement is 8p1 into 7p1. That's it. So what is this equal to? So therefore the required arrangement is equal to 8p1 into 7p1. So what is 8p1? 8p1 is 8, 7p1 is 7. That's equal to 56 ways we can choose. That's it. Very simple problem. There are 8 persons are there. We have to select 2, one chairman and one vice chairman. Condition is given. What is the condition? One person cannot hold 2 positions. So one person cannot be a chairman and a vice chairman. So that is the case. That means out of 8 persons we are going to select any 2. That one is a chairman. So 8p1, if one chairman is selected, then the remaining 8 minus 1 is 7p1 is a vice chairman. So therefore the number of arrangement is equal to 8p1 into 7p1, that's equal to 8 into 7, that's equal to 56 ways. Now move on to the next problem. How many words with or without meaning can form using all the letters of the word equation using each letter exactly once? So how many words can formed with EQUATIN equation with or without meaning can be formed with all the letters of the word using which each letter exactly once, right? Now how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8 letters are there. So this contains 8 letters. 8 letters. Now let us write the letters like this. So there are 8 letters. First, second, third, 4, 5, 6, 7 and 8 letters. Okay. So first letter. This is first letter, second, third, 4, 5, 6, 7, 8 letters. 8 letters. Okay. So there are 8 letters. First, second, third, fourth and fifth, sixth up to 8 letters. Now what is the problem given? So the letters of the word equation using each letter exactly once, that is no repetition is allowed. Suppose out of 8, if you are going to take first letter as 8, so if you chose first letter 8 times, then the second letter, the remaining letters are 7. Similarly, the third letter can be chosen by 6 and the fourth letter can be chosen by 5. Next 4, 3, 2 and 1. So that means first letter can be chosen in 8 ways. In 8 ways we are going to choose. Second letter can be chosen in 7 ways and so on. The seventh letter can be chosen in 2 ways and the last letter can be chosen in 1 way. So that means this can be arranged in how many ways? With or without meaning. So this can be arranged in 8p8 ways. That's it. So with or without meaning, all the 8 letters can be arranged in 8p8 ways. So what is this 8p8? So 8p8 is equal to 8 factorial, right? NPN is equal to, you know what is the formula? NPN is equal to n factorial. This is 8 factorial. 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Since you know the value of 8 factorial is equal to 40320. 40320. 40320 is the required arrangement. That's it. This is how we are going to form the letters of the word equation with or without meaning, right? Now move on to the next problem. What is the problem here? How many words with or without can be made from the letters of the word Monday, assuming that no letter is repeated if 4 letters are used at a time? Certain conditions are given. This is same as that of the previous problem, but here certain conditions are given. 4 letters can be used at a time. All the letters are used at a time. All the letters are used, but first letter is a vowel. So these are the conditions given. Let us find out how many letters are there in the word Monday. This contains 1, 2, 3, 4, 5, 6 letters are there. In Monday, how many letters are there? There are 1, 2, 3, 4, 5, 6 letters. 6 letters, right? Just what is the first condition? 4 letters are used at 4 times, means this implies out of 6 we are going to take 4. That's all. So therefore the required arrangement is equal to 6p4. What is 6p4? Factorial 6 divided by factorial 6 minus 4. So factorial 6 divided by factorial 2, that's equal to 6 into 5 into 4 into 3 divided by 2 factorial gets cancelled. 6 5s are 30 plus 4 3s are 12, that is 360. So we can arrange in 360 ways. That's it. So very simple concept, that is 4 letters can be used out of this 6 in 6p4 ways, that's equal to 360 ways. The first answer. Next, what is the next condition? All the letters are used. So since there are 6 letters, all the 6 letters can be used in 6p6 ways. So all the letters are used, means all the 6 letters can be used in 6p6 ways. So that means 6p6 is nothing but 6 factorial. What is 6 factorial? 6 into 5 into 4 into 3 into 2 into 1. What is this equal to? You know the factorial of 6 is 720. 720 ways we can arrange all the 6 elements. So all the letters are used at a time means 66 ways. That is nothing but 6 factorial is equal to 720 ways. Now the next condition is all the letters are used but the first letter is an vowel. So here all the letters are used but the first letter is an vowel. So that is M-O-N-D-A-Y. So first write down how many vowels. So A, O, only 2 vowels we have. A, E, I, O, U. So there are 2 vowels in this word, right? Now, since there are 2 vowels, all the letters are used, but the first 2 letters is a vowel. So since there are 2 vowels, so out of 6 letters, there are 2 vowels. So that means the first place can be filled by 2p1. The first place can be filled by 2p1. So since there are 2 vowels, the first place can be filled by 2p1 ways. And how many are remaining then? So the remaining 5 places can be filled by the remaining 5 letters with 5p5 ways. So therefore the required arrangement is equal to 2p1 into 5p5. So 2p1 into 5p5. What is this equal to? 2p1 is equal to 2 into 5p5 is nothing but 5 factorial. So 2 into 5 factorial, 5 into 4 into 3 into 2 into 1. So this is equal to 2 into, what is this equal to? So you know factorial of 5 is 120. 120 into 2 is equal to 240 ways. So you can fill. So that means all the letters are used, but the first 2 letters is a vowel can be done in 240 ways. That's it. Okay. Now move on to the next problem. In how many of distinct permutations of the letters in Mississippi do the 4 I's not come together? So here what is the word given? Mississippi. Just first count how many letters are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters are there in the word. There are 11 letters. 11 letters are given in the word Mississippi. Now what is to find? How many of the distinct permutations of the letters in Mississippi do the 4 I's not come together? Now just here in the given word there are 11 letters. How many M's are there? So M, how many M? There is only one M. 1. I, how many I's are there? So 1, 2, 3, 4 I's are there. And yes, how many S are there? 1, 2, 3, 4. 4 S are there. And P, how many P's are there? So 1, 2. 2 P's are there. So totally 4 plus 4, 8 plus 2, 10 plus 1 is 11. Right. So out of these 11 letters, 4 I, 4 S and 2 P and 1 M. Right. Now first find out the total number of permutations. So therefore the total number of permutations is equal to total number of permutations is equal to 11 factorial divided by 4 factorial into 4 factorial into 2 factorial into 1. So if you simplify this 11 factorial divided by 4 factorial into 4 factorial into 2 factorial. So this is equal to 34650. Simplify this, you will get 34650. Okay. Now next condition. What is the condition? The 4 I's not come together. Now let us consider all these I's as one unit. So consider this as one unit. Then remaining, how many letters are there? 4 plus 2, 6 plus 1, 7 plus 1, 8 letters are there. So if no, all the I's are not come together can be arranged in. So if we consider all the I's as one unit, then 4 plus 2, 6 plus 1, 7 plus 1 is 8 factorial divided by the remaining. What are the remaining? 4 S and 2 P and 1 M. So therefore the arrangement is equal to 8 factorial divided by 4 factorial into 2 factorial. So if we simplify this, 8 factorial divided by 4 factorial into 2 factorial is equal to, this is 8 into 7 into 6 into 5 divided by 2. So this is equal to, this gets cancelled. What is this equal to? 4 into 7 into 6 into 5 is equal to 840. That's all. Okay. What is the conclusion? Therefore, the number of distinct permutations of the letters do the 4 I's not come together is, therefore the required arrangement is equal to 34650 minus this 840. That's it. So if you subtract 840 from this 34,650, you are going to get 33,810. So this is the required permutation. So this is the required answer. So therefore the required arrangement is equal to, just take the difference between these two, that will give the required arrangement. Now move on to the next problem. In how many ways can 4 red, 3 yellow and 2 green discs be arranged in a row if the discs of the same color are indistinguishable? So in how many ways can 4 red, 3 yellow, 2 green discs be arranged in a row if the discs of the same colors are indistinguishable? right? Now what is the problem given? So what are the given conditions? There are 4 red and 3 yellow and 2 green. So totally 4 plus 3, 7, 8, 9 colors are there. So in how many ways can 4 red, 3 yellow and discs? So there are 9 discs are there. Okay. So here the 3 discs are of different kinds, different colors are given. So one is red, another one is yellow, another one is green. So the 3 discs are of different colors. So therefore the required arrangement. So therefore the required arrangement is equal to 9 factorial divided by 4 factorial into 3 factorial into 2 factorial. That's it. See, in how many ways can 4 red, 3 yellow and 2 green discs be arranged in a row if the discs of the same color are indistinguishable? Since there are 4 plus 3 plus 2, 9 discs, all the discs are of different kinds, different colors. So therefore the required permutation is equal to, required arrangement is equal to 9 factorial divided by different 4 factorial divided by 3 factorial into 2 factorial. So this is equal to 9 into 8 into 7 into 6 into 5 into 4 factorial divided by this 4 factorial as it is, 3 into 2 into 1 into 2 into 1, 4 factorial gets cancelled, 3 into 2 is 6 gets cancelled, 2 4s are 8 gets cancelled, 9 into 4 into 7 into 5, that is equal to, what is this equal to? The simplified answer is 1260 ways. That's it. This is the simple answer. Okay, very simple. Now move on to the next problem. Find the number of arrangement of the letters of the word independence. Independence, in how many of these arrangement do the words start with P? So there are certain conditions given. Find the number of arrangement of the letters of the word independence. This is same as that of the previous problem. What is the first condition? Do the words start with P? Now just find out how many letters are there. So in the word independence there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters. So there are 12 letters in the word, 12 letters are there, right? Out of which find out how many I. So how many I's are there? 1 I. Then N, how many N? So N contains 1, 2, 3 N's are there. D, how many D's are there? 1, 2, 2 D's are there. Then E, how many E? The letter E is 1, 2, 3, 4 E's are there. Then so P, only 1 P, the remaining 1, P is equal to 1. E already we taken, V there are 4, N is also taken, D is also taken, and 1 C, C is 1. So count it, 4 plus 1, 5 plus 1, 6, 6 plus 2, 8, 8 plus 3, 11 plus 1 is 12 letters, right? So the given word in independence contains 12 letters. So out of which there are 3 N's, 2 D and 4 E and all remaining 1 letters, right? Now just find out the required arrangement. So therefore the required arrangement is equal to, here the required arrangement is equal to 12 factorial divided by, so 4 factorial into 3 factorial into 2 factorial. This is the required arrangement. So if we simplify this, what is the answer you are going to get? 166 3200. So this is the required arrangement of the letters of the word independence. Now what is the first condition given? Do the word start with P? Okay. Now let us fix the word P in the left extreme position. Then how many letters are there? So 12 minus 1, there is 11 factorial divided by, so divided by, what is left over? 3 factorial, 2 factorial into 4 factorial. That's it. So that is equal to, how many N's are there? 3 factorial into 4 factorial into 2 factorial. So do the word start with P means, let us fix the word P in extreme left position. Then the number of arrangement can be done in 11 divided by 3 factorial into 4 into 2 factorial. This is equal to 138,600. That's it. Okay. Simplify this. So this is how we are going to solve this problem. So there is only one condition is given, that is find the number of arrangement of the letters of the word independence. That is, so the number of arrangement is equal to 12 factorial divided by 4 factorial into 3 factorial into 2 factorial, that is 1663200. Since first condition is given, in how many of these arrangement do the words start with P? Now let us fix the first letter P in the left extreme position. Then the number of arrangement can be done in 12 minus 1 is 11. 11 divided by the remaining 3 into 2 into 4 factorial, that can be done in 138,600. This is how we are going to solve this problem. Okay. So that's all regarding today's sessions. Hope you followed all the problems. These problems are very important for the point of examination. So that's all regarding today's session. Let us meet with the different types of problems in the next session. Thank you. Thank you very much.